In this video, we're going to take a look at section 5.3 on dividing polynomials. The first type of problem that you will encounter is dividing by a monomial, which means a polynomial of a single term. So here we have 40 x to the 8th power y to the 9th power minus 20 x to the 6th power y to the 7th power plus 45 x squared y. That polynomial is being divided by 5x squared y. That's just one term because there's no other things that are being added or subtracted, and so this is just one term, which makes it a monomial. When you're dividing by a monomial, there's a shortcut for doing the division, which is just to set it up as a fraction. And then, so I guess that'd be the first step. And then the second step would be divide the monomial. Whoops, I don't know what I'm putting there. Divide the monomial. Maybe it's just easier if I show this instead of writing it out. Into each term of the numerator. So it really isn't the best description for it, but you'll set it up as a fraction, and then you take the denominator and divide it into each term of the numerator and simplify. So we'll write this as a fraction. We'll have 40 x to the 8th power y to the 9th power. Go ahead and write that out. Minus 20 x to the 6th power y to the 7th power. Let's get that 7 there. Plus 45 x squared y, and that whole thing's going to get divided by, so we put a fraction bar underneath the whole thing, 5x squared y. Now this trick only works when it's a monomial. We take the denominator, the whole thing, the monomial, divide it into each term of the numerator. So basically we're splitting the big fraction up into separate fractions. So we'll have 40 x to the 8th power y to the 9th power over 5x squared minus 20 x to the 6th power y to the 7th power over 5x squared y plus 45 x squared y over 5x squared y. And because it's a monomial, we don't have to factor this to get things to cancel out. They're already factors. We can just start crossing things out. So the 5 cancels out with the 40. It leaves me with an 8. I can cancel out 2 powers of x. So I'll have 6 left over up here. And 1 power of y. So I'll have 8 left over. So we'll have 8 x to the 6th, y to the 8th power left over from the first term. Here the 5 cancels out with the 20. It leaves me with a 4. 2 powers of x. I'll have 4 powers left over. 1 power of y. I'll have 6 left over. So we'll have 4 x to the 4th power, y to the 6th power, plus 5 cancels out with the 45. It leaves me with a 9. Both powers of x cancel out. The single power of y both cancel out. And we'll just have 9 left over here. And that's divided. So this would be our final answer here. All right. So you set it up as a fraction. Divide the monomial, the thing you're dividing by, into each term of the numerator. I'm really unhappy with the wording there. This is how I normally say it. Divide the denominator into each term of the numerator. You can always do that, but it only works when it's a monomial. All right, so let's take a look at another example. We'll do the same thing. We have 20, it's already set up as a fraction. What am I doing? Okay, so we'll just go, well, I guess I'm gonna have to rewrite it anyways. 25, a to the 8th power, so we'll take this monomial, divide it into each term of the numerator. Right? So I'll have 25 a to the 8th power over 5a to the 3rd power minus 25 a to the 6th power over 5a to the 3rd power plus 20 a to the 3rd power over 5a to the 3rd power. And then we just cancel things out. So the 5 cancels with the 25, leaves me with a 5. 3 powers of a cancel out, so I'll have a to the 5th power left over in that first term. 5 cancels out with the 25, leaves me with a 5. 3 powers of a, so I'll have a to the 3rd power left over in the second term. 5 cancels out with the 20, leaves me with a 4. All 3 powers of a cancel out, so we'll just have 4 left over there. And this would be my final answer from dividing in this situation. All right, so that's how we divide by a monomial. So your first couple of problems, that's what you'll be doing. Then it's going to move to dividing by a binomial. Right? And in order to divide by a binomial, which is a polynomial of 2 terms, you cannot use that same process that we just used. Unfortunately, if you could, I would advocate to continue doing it that way. If you try the c plus 3, if you try to divide it into each term of the dividend here, you'll get c squared over c plus 3. So you don't get to split up the c and the 3. Those have to stay together. Your denominator is stuck together. So you'll have c squared divided by c plus 3. And nothing will cancel there because these are terms. You'll have 7c divided by c plus 3. Nothing cancels because these are terms. So nothing happens if you try to do it that way. Nothing gets divided. So to divide when it's a binomial like this, we'll have to use long division of polynomials. And this works in a very similar way as long division of numbers. So we're going to take the thing we're dividing by, which is the c plus 3, we'll put that on the outside, and then we'll set up this contraption here, and on the inside we put the thing we're dividing into, c squared minus 7c minus 60. And so the way this works, so the question you want to ask yourself is, what do I multiply to the first term of my divisor, which is c, to match the first term in my dividend, which is c squared? What do I multiply to c to match this c squared? And the answer is another c, right? C times c will match that c squared. So that's what we're going to write up here. So whatever you need to multiply to this to make it match this, that's what you write on top. And then you'll go ahead and multiply it. So we'll take c times c, which is c squared. So these match each other. It's very critical that the first terms match. If they don't match, you're not making any progress. However, because there's 2 terms here and I'm multiplying, we have to distribute. So the c also gets multiplied to the 3. So I'll get c times 3, which is positive 3c. So this is what we get. This is matching this as close as we can. With numbers, you try to get as close as you can without going over. With polynomials, you get as close as you can by matching the first term. So these match. Then we want to see what's left over, right? We got as close as we could. Now what are we still dealing with? What's left over from this? And so we want to subtract. But because there's 2 terms here, we have to distribute the minus sign. So I need to subtract the c squared, but also subtract the 3c. So that will also change sign. Then you combine like terms, and what should happen every time when you do this, the highest power of your variable should cancel out. So c squareds cancel out. I get negative 7c minus 3c, which is going to give me negative 10c. You bring the negative 60 down, and then you just repeat that process. What do I multiply to c to match this first term here, which is negative 10c? I'm going to multiply by negative 10. Whatever I choose to multiply by has to get distributed to both of these. So we get negative 10 times c, which is negative 10c. So these match each other. Negative 10 times 3 gives me negative 30. Then I go to subtract this to see what's left over, which means both of these will change sign. These will both become positive, right? This will become positive 10c. This will become positive 30. Then we combine like terms. The highest power of c cancels out. And when we combine these together, we have negative 30 left over. And so my answer, my quotient, is the c minus 10. That's the quotient. And my remainder is negative 30. Now, I'm not sure, based on what I've captured of the problem from Math Excel, how they want us to format the answer. The directions don't have that information. You might be asked to just type in the quotient and the remainder into 2 separate boxes. So it'll say the quotient is blank, and you type in c minus 10. And then it'll say the remainder is blank, you type in negative 30. The other way, so that's kind of what I already have here. The other way you might be asked to format the answer is to take the quotient plus the remainder. And the thing about the remainder, I don't know, you probably remember this in grade school when you first learned about long division. You would say, okay, my remainder is negative 30, so I'll have r negative 30. You put r there with negative 30. And that really never made sense to me, and it doesn't really show you how that remainder connects back to the rest of the problem. What's happening with the remainder is it's still getting divided by the divisor. So the remainder should still be divided by whatever the divisor is. And that's how every division problem ends up. Right, so the quotient in this case was c minus 10 plus the remainder, which is negative 30, over the divisor, which was c plus 3. And so this would be another way of writing the answer and putting it all back together. All right. Okay, so that'd be the result for that problem. All right, let's look at a couple more of these before we go on to our last topic. Now, some students will look at a problem like this and think, oh, I figured out the pattern. Whatever number is here, that's the number I want to use up here, but with one less power of c. And that is true for this problem, right? We have a 1 here, we use a 1 here, and then instead of c squared, we just have c. We do the same thing here. We have negative 10 here, we use negative 10 up here, just one less power of c. That's only going to work if the divisor is as simple as what you see here. The variable plus a number or the variable minus a number, and that's it. If it's any more complicated than that, you're going to have to do the problem the way I was just describing it. Here, this 4 here makes it more complicated where that shortcut doesn't work. So you have to do it the way I was mentioning, which is we'll put the 4w plus 5 outside, and then inside we're going to put the 20w to the third power. Try writing that again. Plus 17w squared plus 22w plus 45 goes on the inside. And then you have to ask yourself the question, what do I multiply to the 4w to match the 20w to the third power? That's the only way to do this. There's no other shortcut really. And so what you need to multiply by to get the 20 is you'll need to multiply by 5, right? 5 times 4 is going to give me the 20. And then I already have 1 power of w, but I need to have 3. So I need to multiply by 2 more powers of w. So 5w squared times 4w gives me 20w to the third power, and so they match. But I also have to multiply it to the second term here. 5w squared times 5 gives me 25w squared. Right. Then we subtract. So this will become negative, and this one also becomes negative. The highest power of w cancels out, and what results from combining these together is we will get negative 8w squared. We bring down the next term. I forgot to mention that in the last example. I think I just automatically did it. And then we repeat the process. What do I multiply to 4w to match the negative 8w squared? I'm going to multiply by negative 2w, right? Negative 2 times 4 will give me the negative 8. W times w is going to give me the w squared. So negative 2w times 4w gives me negative 8w squared. But then I also have to multiply it to the second term here. Negative 2w times 5 will give me negative 10w. We change the sign, right? So we're going to subtract this. So that means this will become positive and this will become positive as well. The highest power of w cancels out. I combine these together, I get 32w. Bring down the last term here, which is 45, and we'll have to go one more round, right? So what do I multiply to 4w to match the 32w? I just need to multiply by 8. 8 times 4 will give me the 32, and I already have the w here, so I don't need any more w's. 8 times 4w gives me 32w. 8 times 5 is going to give me 40. Then we go to subtract, so make sure you don't forget that. I get students that will do it the first time and then they forget to do it for the rest of the problem. Subtract every time, and I'm sorry, I'm really just out of room here, but I think you can see the answer here is going to be 5. Okay, so 5 is my remainder. My quotient is 5w squared minus 2w plus 8. We could format our final answer the same way we did the last problem, 5w squared minus 2w plus 8 plus the remainder, which is 5, that's still getting divided by the divisor, which is 4w plus 5. So this would be another way of writing the same answer. All right, let's take a look at the next example. All right, so here we have 16b to the third power plus 8b squared plus 68 divided by 4b plus 16. So we'll set this up the same way we did the last couple of examples. We're going to use long division. So we're going to have, okay, that's kind of weird. Let's try that again. Okay, 4b plus 16 divided into 16b to the third power plus 8b squared plus 68. All right. So we'll get started by asking the same question we did on the last couple of examples. What do I multiply to 4b to match this first term here, which is 16b to the third power? Well, to get 16, I need to multiply the 4 by another 4. And then to get the b to the third power, I'd have to take the b and multiply it by another b squared. B squared times b is going to give me b to the third power. So 4b squared times 4b gives me 16b to the third power, so these match up to each other. And then 4b squared times 16 is going to give me 64b to the second power. Right. Then we go to subtract to see what's left over from this. The highest power of b cancels out, which is good. And then this will get negative 56b to the second power left over. Now here's where some things kind of become a little more complicated because we are missing b to the first power from our dividend. My preference for dealing with that is just to leave an empty space, which you see I've already done. You don't want to bring the 68 down. So that's a mistake a lot of students will make, is they'll have the plus 68 here, they bring down the 68, and then it kind of gets in the way. It doesn't fit with whatever else is going on. So either leave an empty space, and then when you go to bring this down, you're just bringing down an empty space. Nothing gets filled in here. Or you can do what Math Excel is going to suggest, which is use 0 as a placeholder. We have 0 b's, so we'll just put 0b there, and that way you have something to actually interact with, right? So we'll bring down the 0b, and we'll continue the process. What do I multiply to 4b to match the negative 56b squared? Well, you might need to get a calculator out for that. So what do I have to multiply to 4 to get negative 56? It's going to be 14, negative 14. Right. And then to get the b squared, I need to multiply another b here. So negative 14 times 4b, sorry, I'm saying the wrong thing. Negative 14b times 4b will give me negative 56b squared. And then negative 14b times 16, I was really trying to avoid having to get a calculator, but now I think I've reached a point where I need one. So let me go ahead and calculate that real quick. I could probably try to figure it out in my head, but I don't want to try. So, and I might get it wrong anyways. So it should be 224 is what I'm getting. So negative 224b, right, is what we'll get when we take negative 14b times 16. Don't forget this very important step. Change the sign of both of these terms because we want to subtract this. The negative sign gets distributed and these both become positive. The highest power of b cancels out. 0b plus 224b will stay 224b. Now we bring down the 68 and we finish the process one last time here. So we have one more round to go. What do I multiply to 4b to get 224b? I'm going to take the 224 in my calculator, divide it by 4, and I get 56. So I need to multiply by 56, and we already have b, so we don't need to add any more b's in there. So we'll get 56 times 4b, which is 224b, and then 56 times 16. Again, I'll use my calculator, and I'll get 896. Then we go to subtract, so this will become negative, and this will become negative. The highest power of b cancels out, and we'll get, let's see, we'll subtract those, and we'll get negative 828. So things got a little bit silly there with the size of these numbers, but this would be my remainder. This would be my quotient. Whoops. It should include the 6 with the 5. All right. And we could also write the answer like this. 4b squared minus 14b plus 56 plus the remainder, which is negative 828 over the divisor, which is 4b plus 16. And so that would be my final answer. So that's how long division works. But the next topic is, oh, sorry, I guess we have one more long division topic. Let's see, okay, yep, sorry. Okay, I thought there was only 3 examples, but there's 4. So maybe this would be a good one for you to try. This one kind of seems like it's here as an example for my students to try when I'm teaching this in my face-to-face class. So as a viewer of the video, this might be a good time to pause the video, see if you can do this problem that's currently on the screen, and then resume the video to see the solution. All right, so what you're going to do is take r plus 2 and divide it into r squared plus 4r plus 32, and you'll set it up like this using long division. What do I multiply to r to get r squared? I multiply by another r. R times r gives me r squared. R times 2 is going to give me 2r. We subtract. I like to use different colors to make everything kind of stand out, which means both of these become negative. So I kind of chose poorly with my examples, I feel like, because every single one of them, both of the terms in the divisor were positive. So just be careful. That's just a coincidence on my part. I happened to pick one where everyone was positive every time. So it's not that these will always be the same sign, right? My examples have had that be the case. But if this was r minus 2, for example, then this r squared would become negative and this 2r would become positive. So whatever sign they currently are, they will switch. So just be careful with that. And then combine like terms, we'll get 2r. Bring the next term down. Repeat the process. What do I multiply to r to get 2r? I multiply by 2. All right, 2 times r will give me 2r. 2 times 2 is going to give me 4. Don't forget this very important step of subtracting. The highest power of r cancels out. 32 minus 4 is going to give me 28. So 28 is my remainder. R plus 2 is my quotient. I can write this as r plus 2 plus the remainder, which is 28, over the divisor, which is r plus 2. All right, and so that would be the final answer there. Okay, so there's another topic here for dividing called synthetic division, which is a shortcut that we can use, but only in certain cases. Just like the method for dealing with the monomial only works when you're dividing by a monomial. So it's a process that works only in a very specific case. The same is true for synthetic division. But it's a much more common case, so it's a really useful one to know. So we can only use synthetic division if the divisor is of the form x minus c. And you actually kind of want to remember that as a formula. So we're dividing by x minus c. As long as the divisor fits that formula, we can use this shortcut called synthetic division. So let's go ahead and take a look at how that works. All right. So notice my divisor here fits the formula of x minus c. It's a w instead of an x, but again, it's the variable by itself minus a number. So it matches up perfectly. So the way synthetic division works is you strip out the variables and you focus on just the numbers, the way the numbers behave. So the way you're going to set it up is outside the box at the top, you're going to write whatever c is equal to. And c is the number from this little formula here. So notice that c is what comes after the minus sign, which in this case will be the number 5. So c will be positive 5. You got to be careful about that, because a lot of students will see the w minus 5 here and they think c is negative 5. But in fact, c is the opposite sign of that number. It's going to be positive 5. And then across the top, inside the box, you're going to write your dividend, but just the coefficients. No variables are allowed here. Just the coefficients, just the numbers in front of the variable parts from highest to lowest power. So we'll start with w to the third power. The coefficient here is a 1, so I'll put a 1 here. Then w squared, the coefficient's negative 9. W, the coefficient's 40. And then the constant term, the coefficient's negative 17. I'll try to write two numbers at once there. So let's undo that. Okay, negative 17. So this is from highest to lowest power. Right? And the way this process works, usually I like to explain things verbally, like using words, but it's kind of hard to do with synthetic division. It's easier just to show. So I'm going to show you how the process works. First, we take the first number here and drop it below the box. This is where your answer is going to show up down here. Whatever number you have here, you multiply to c. So you're going to multiply. 1 times 5 gives me 5. You write the result underneath the next number inside the box. So I'm going to write 5 here underneath the negative 9. Then you add that column of numbers together. So we're going to add. Negative 9 plus 5 gives me negative 4. And then you just repeat that process all the way till you get to the end. Negative 4 times 5 would be negative 20. Write that result underneath the next number inside the box. Add this column together, we get positive 20. 20 times 5 is 100. Add these numbers together and you will get 83. All right. And amazingly, surprisingly, we have just divided these two polynomials. The problem is our answer's right here, but the variables are missing from our answer because we took them out of the problem. So we need to put the variables back into our answer. So the way you interpret this result is the last number that you have over here on the end is the remainder. So 83 is the remainder. And then all the numbers in front of the remainder are your quotient. But it's just the coefficients. It's missing the variables, but it follows the same pattern. It goes from highest to lowest power, and it ends on the constant term. So 20 is my constant. The -4 is my coefficient of w to the first power. The 1 is my coefficient of w to the second power. And so on and so forth. If there was another number to the left, that'd be my coefficient of w to the third power. So I kind of like to work backwards, starting from the last number as my constant, and then going up by 1 power of w from there. Another way you can do it is whatever power you started with, so we started with w to the third power as the highest power, your quotient will be 1 less than that. It'll start with 1 less than whatever the highest power is. So it'll start with w squared. And so this would be my quotient. And again, we could write our final answer in the form of quotient, which is, and when you go to type this on Math Excel, don't type the 1. I just put that there so you can see, how I got that result, right? I took the 1 from here and put it here. But when you go to type that in, the 1's not necessary. Math Excel is not going to like that. So we'll have w squared minus 4w plus 20, that's the quotient, plus the remainder, which is 83, over the divisor, which is not 5. A lot of students will say, oh, I divided by 5. You didn't divide by 5, you divided by w minus 5. So your divisor was w minus 5. And this would be the final answer. All right, so that is how synthetic division works. I know it looked a little messy, but if I don't draw the arrows and what's nice about synthetic division is it's composed of simple operations. Simple multiplication, simple addition for the most part, unless the numbers get crazy. And so it goes very quickly. It's much faster than doing long division. So if you practice it a little bit, I think you'll find you prefer synthetic division where it's possible to use. Now you cannot use synthetic division on some of these earlier problems, right? Like this one. Synthetic division does not apply because the divisor doesn't fit the formula. There's a 4 in front of our variable, so synthetic division doesn't work. We could have used synthetic division on this example. It does fit the formula, right? So where possible, I think you'll prefer using synthetic division if you learn how to use it. All right, so let's go ahead and do this one. Again, by synthetic division, it does fit my formula of x minus c. C in this case will equal -2, not +2, right? If you think c is +2, we'll plug it into the formula. What do you get? You get x minus 2, which doesn't match the thing we're dividing by. We want a +2 there. So to get a +2, we have to plug in -2 for c. Minus -2 is going to give me that +2. So c is -2, so let's go ahead and set up our synthetic division. -2 goes on the outside. The coefficients here from our dividend go across the top on the inside. So 2, 7, 3, and -8. Make sure you're going from highest to lowest power. Drop the first number below the box to get started. So drop the 2 here. I like to put an arrow. If you look on Math Excel, they just leave that space blank. But then I see students sometimes filling it in with other things that they're not supposed to. So I put an arrow there that kind of occupies that space so that I don't put anything else there. So 2 times -2 is -4. Add those together, we get 3. 3 times -2 is -6. Add those together, you get -3. -3 times -2 is +6. You add those together, you get -2. And just like that, I'm done. The remainder is -2. The quotient will be, make sure you use the variables from the original problem. It's going to be 2b squared plus 3b minus 3. And that's the quotient. All right. And so that is how synthetic division works. It's very quick. All right, let's try. I have 2 more examples, it looks like here. So I'm going to do this one, maybe, and then let you have the opportunity. I guess at any point in this video, you could always take this opportunity of pausing the video and seeing how to do the problem. But that's what I'm saving the last one for. So this one has a quirk, like we saw earlier. We're missing a power of a. We have a to the third power, a squared, and then a to the first power is missing. So that's another thing we'll have to be careful about when we set up synthetic division. C in this case is equal to 4, right? It's positive 4. It's going to be the opposite sign of that number. The dividend from highest to lowest power is going to be 1 for a to the third power, negative 8 for a to the second power. The next number here has to reference a to the first power because synthetic division is expecting acknowledgement for every power of a starting from the highest one. So if we want this to be a to the third power, this one has to refer to a to the second power. The next number has to refer to a to the first power. Since we don't have an a to the first power, we put a 0 here as a placeholder. And then the last number is going to be our constant. Right? So if you're missing any powers of your variable, use 0 in its place when you're doing synthetic division. All right, so let's go ahead and carry this out. We'll drop the 1 below the box. 1 times 4 is 4. Add those together, we get negative 4. Negative 4 times 4 is negative 16. Add these together, you still have negative 16. Negative 16 times 4 is negative 64. Add those together, you get negative 56, and we are done. All right, the remainder is negative 56, and the quotient here will be a squared minus 4a minus 16, which we, again, can write as a squared minus 4a minus 16, plus the remainder, which is negative 56, over the divisor, which is a minus 4. All right. And so that would be the final answer there. So like I said, much faster than long division. Not only is it worth your while to save you some time on some of these problems, but in college algebra, there is a topic in that course that takes up a couple of sections where there's a lot of division going on, and you'll have to learn synthetic division to do those problems as well. So it'll help you later in your studies. All right, so if you haven't already done this, go ahead and pause the video. Give this problem a try on your own, and then resume the video to see the solution. So in this case, kind of a redundancy here. It's kind of similar to the last problem. C is equal to 4. So we're going to put 4 on the outside here. Across the top inside the box, we'll have 1, negative 6, 16, and negative 14. Right? We don't need any zeros here because every power of v is accounted for. We'll drop the first number below the box. 1 times 4 gives me 4. Add those together, you get negative 2. Negative 2 times 4 is negative 8. Add those together, you get 8. 8 times 4 is going to be 32. You add these together and you will get 18, I believe. All right, and so the last number is my remainder. And then my quotient will be all the numbers in front of that, and it'll be v squared minus 2v plus 8. And so that's the quotient. And again, you might have taken the time to write this as v squared minus 2v plus 8 plus the remainder, which is 18, over the divisor, which is v minus 4. All right, so that concludes the video on section 5.3, which was on the topic dividing polynomials.